Hello, calculus fans. Okay, so now we're going to talk about a new concept. This is integration by parts. Now we've studied the substitution rule, and we want to think of that as the anti-differentiation counterpart to the chain rule. So now we're going to come up with an anti-differentiation counterpart to the product rule. So remember, the product rule says is that if we have differentiable functions, f and g, then the derivative of the product, f of x times g of x, is equal to f of x, g prime of x, plus g of x, f prime of x. This is useful for differentiating products. Now I'd like to rewrite this using our notation for indefinite integrals, which is computing antiderivatives. And just for convenience, for now, I'm going to leave off the plus c. So if we have a derivative, then we can turn this around and write it as an antiderivative. So an antiderivative of f of x, g prime of x, plus g of x, f prime of x is going to be equal to f of x, g of x. And again, I've omitted the plus c for now. All right, so let's run the integral through the sum. Remember, if you have an integral of a sum, it's the sum of the integrals. And then I'd like to rearrange things just a little bit more. I would like to take this piece here and move it to the right side. And if we do, this is the equation that we get. And this is our integration by parts formula. Okay, so it's a little hard to see how we're going to use this. We'll talk more about that as we move on. And we're going to write a shorthand notation for this. Instead of writing f of x and g of x, let's call f of x u, let's call g of x v, and then I can say that du is equal to f prime of x dx, and dv is g prime of x dx, and that allows us to write this in a much more compact way. This is our new integration by parts formula, that the integral of u dv is equal to uv minus the integral of v du. And as I said, this is just a compact version of the same formula. You can remember it either way, it doesn't really matter. Okay, that's all for now.